everyone for coming. My name is Laurent. I work for Spotify for about 2 years, and I'm passionate about development, fast development, efficient development, and human beings. Today, we're going to talk about what does it take to scale continuous delivery, continuous integration when you have a lot of more information than before, when you have a lot more developers, and actually the stuff you learn in school, the continuous delivery, so on, doesn't quite work so well. So, all of us here, all of us, we are humans. You are humans. What does that mean, really? It means, first, we build relationships. I'm building some with you. You're building some with other people in your team. You're building relationships with your customers. That also means that you learn. You learn from your mistakes. You learn from your successes. You actually learn a lot more from mistakes than from successes. You learn from your peers. That also means that you can make concepts. If you have a lot of code you work into, you typically try to conceptualize them, make sort of objects in your mind, so you can abstract away things. And that enables you to talk with each other. You tell stories. That's what I'm doing now. I'm telling you a story. Hopefully you can remember it. You're probably telling stories to people around you, including your kids, maybe. You dream of new solutions. We've heard, like this morning, that people in GitHub dream of new solutions for open source development. In Spotify, we dream for like the best music at the best time for you. And that enables you to create. You create new things. You can like imagine new ideas and actually do it. So you know that. You have a fantastic team in your startup. So of course, you want to enable all your developers to create new stuff together. And for that, because you know, you read that, you open a book, you created a perfect continuous delivery system. So you know that, you've done right. Continuous integration, now you have like 1, 2, 3, 10, 15 different agents running builds for a given commit. You got tons of information that come back to you. Of course, you thought like unit tests because you know, right? I mean, unit tests, they work, they deliver you good value. If they fail, you should fix it immediately. All of that, fine. You created performance tests. By the way, every single test is a performance test. You just have to see how long it takes to run. And of course, you got more tests, integration tests, system tests, like whatever you want to call them. You got tons of tests that have been pushed into your system. And they deliver like value to a certain extent. They tell you if something goes wrong or right, mostly when it goes wrong. You know how to do that. You create small increments, and you deploy that with containers of some sort, some Docker or whatnot. And you orchestrate all of that, and you think you're going to be able to scale pretty well, because you deploy that each and every time you can, like potentially several times a day or even several times an hour. But really, what you realize is that after a while, you move to more like 100, 200 developers, and when you hire more developers, you actually don't go any faster. Something is wrong. You're sort of a plateau, if you see what I mean. Like, it doesn't quite scale. So it's probably a problem of information overflow. You just have too much things to process as a developer. You get too much information from people around you. So let's just take one step back for a minute and understand what does it take to scale. What does it take to scale with continuous delivery? Well, what you realize in teams is that the teams are mostly efficient when they are somewhere around 7 to 8 or 9 developers. Over that, the entire team slows down. So if you put 11 developers in a team, it's going to go slower than 10. Don't do that. Why is that? Probably a question of complexity, too much information to process from other people around you. You also realize that the teams which are really fast are autonomous from each other. So it typically means that if I'm a team and I need to upgrade some schema somewhere in a database, and the other team is not ready to do that, then we basically have to wait for each other and we slow down. So it's much better if we all have our own part of the database that we can upgrade when we want. or switch to another language, or whatever other thing. So you want to avoid having synchronization points between the teams. They need to be clearly autonomous. And that's something we value a lot in Spotify, having people basically being able to go at their own pace. Dependencies. It's a myth to think that teams don't depend on each other. They do. In Spotify, everyone wants to access like how to play music. It helps. So you want to create an environment where the different teams are kind of do not depend on each other too much. And if there is a bug in some other part of the system, you don't want them to impact you. We'll look at that a bit later. Large code base. You're going to work as a developer for about 30 years. 30 years is roughly 1 billion seconds, right? So now you got weekends, you got nights, you got meetings. What's left is somewhere around 200 million seconds in your professional life to develop. That's roughly what it is. Now, let's say you go into a 20 million lines code base. If you need to read that from the beginning to the end and spend an average time of 10 seconds on every line to really understand it, it's going to take your entire life. Think about it. It means that if you want a developer to be able to fix a problem in 5 minutes, you need to shrink 30 years of work into 5 minutes. That's what it takes. So you cannot force people to understand about like 1 million lines of code. It just doesn't work. The thing that works pretty well in a team, if you want to scale, is that people need to be able to keep track of what's happening around them. It has to do with the size of the team, meaning I understand everything around me. I understand the world I live in. I understand that this other person is doing something on a database while I'm doing something on the front end. And I sort of keep all of that in my mind. I understand those things. The thing is, people make mistakes, and the impact of a mistake has to be small. So let's say you have 200 developers, and each of those developers make one mistake every second year, like a bad mistake, something that breaks your code badly, potentially in production, because you deploy, of course. Well, that means that you have a pretty bad situation every second day, on average. So basically what that means is that it's okay to fail, but the impact of something broken should be pretty small. Coffee. We cannot underestimate or overestimate the importance of the coffee machine, well, for me at least. But because the person you talk with on the coffee machine, if you cannot talk directly into the deep problem, like in depth into your problem with the person you have in front of you at the coffee machine, then you got a problem of communication with the other person. If you stay at a high level, well, we got this type of problem, high level whatnot, fine, but then you cannot really get good information at the coffee machine. The person you see at the coffee machine, you need to be able to go deep into your issue with them. That means that it needs to be kind of constrained in terms of complexity. And of course, you need to trust people. What that basically means is that I know that if I'm asking someone to do something and they don't do it, I know that it's because they have a good reason for that. It's just not because this is this other team in this other room somewhere. And of course, they don't make priorities correctly because that's my priority that counts. So, and also, of course, we've got 10 million lines of code or whatever. If you build that, it's going to take a few hours, and it's really, really bad for velocity of your team. So we have to rethink. Basically, millions of lines of code, hundreds of developers. You have a real problem. So let's think about it. Do we have limitations? I mean, we can dream, we can do fantastic things, but we also have some limitations. And the problem so far has been that we have all built our continuous integration, continuous delivery systems based on technical assumptions. But did we really take the human into account? So we also have some limitations that we need to introduce in that. First one is, I'm sorry to tell you, but your short-term memory is kind of small. That's what it is. I'm not saying that. Just Google that. Basically, that means that when you build like notions into your brain and you try to understand something which is new to you, that's the number of things you can put in your brain. You have what we call combined knowledge. What is combined knowledge? It's a knowledge that you don't even realize you have. You basically execute, when you see a problem on the screen, you sort of know where it comes from. So click, 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 and you go directly to the place where it is. Right? You sort of some people call that culture or experience, if you want. That's basically the same thing. You want to help people have this, get used to, use this combined knowledge that they have. You cannot multitask. Like, stop that. You cannot multitask, period. Like, stop. People say they can. It's not true. So if you can multitask, if you can look at your phone right now, it's probably because you're overpaid. Because if you can multitask, it's because you don't do something smart enough or complex enough. You cannot context switch so far really well. If you have to context switch, you will typically take 7 to 10 minutes to get into something complicated. So if you read your email every 15 minutes, you do nothing during your day, or nothing smart. You can go to a certain level of abstraction levels, but not that far. If I produce data, you can probably compute the average. You can probably compute the distribution, something. And you can also take one step further and say, well, I'm going to be able to compute the probability that my average is right, or how right it is. But if I'm asking you what is the probability that your probability is right, you're like, really? What does that mean? It has a meaning from a mathematical point of view, but it doesn't really mean anything for us. So you need to avoid having to go too far into abstractions. And you hate uncertainty. If you develop something and you have a bug, you don't want to question the compiler or the OS. You want to question your code. As some people say, select is not broken. Don't try to check if the select is wrong in your database. It's not, right? Look at your code. We tend to remember pain if we do something really difficult, and at the end of the day, we realize that we wasted our time, and consciously, we will try to avoid doing those things again. We will try to, okay, maybe I should read that email first before I go into that problem, because last time I did it, it was so painful. And we like treats, right? Like everyone else. When it's funny to develop something, we like to do it. So this is like the limits we have to deal with, and we need to introduce that into our development processes: continuous integration, continuous delivery. So here they are. So we're going to look into like what we need to do and what we're doing right now in Spotify in order to like use these things or take them into account. So first is you need to be really, really fast at giving feedback to your developers when it comes to building or to testing or whatnot. And by really fast, I mean seconds. Not minutes, not half an hour. It has to be in seconds if you can. So you need typically to use Bazel or Buck or like incremental builds of some kind. You need to be able to start the tests that are most likely going to fail and so on and so forth. Why is that? Because after a few seconds, people tend to context switch. And after they've done that, it's super hard to come back. So typically what we do is that we monitor the time it takes to build stuff on the developer's machine. And we make average and the percentiles and so on, and we try to shrink, even if you're talking about millions of lines of code. We also monitor, for instance, the time it takes for a developer when they submit a PR that it gets approved. Should be in minutes, if possible, hours maybe, but certainly not days. So you really want, like, if I submit a pull request, someone has to look at it now, or really quick. Otherwise, if you come back 1 day later, I'm just like out of context and I totally forgot what I just did. Consistent results. Of course, nobody ever tries to build with the latest from the internet, right? You don't do that, right? No one builds NPM stuff, JavaScript stuff using the latest version of any software on the internet, do you? Like, no one does that, right? But for those who do, that's a bad idea. Why is that? Because you're going to build things twice, and it's not going to give you the same results. It's really, really bad. So let me give you one example. So we make statistics, and so these are the different builds on the x-axis, and the y-axis is the results. So green is good, whatever is not green is not good. That's really not something you want to deal with, right? I mean, whenever there's a new build on the same SHA, you get different results. You hate it as a developer. You don't know where to look for, right? So you want to avoid that thing. You want first to visualize it so that you are able to fix it. But this type of thing, you really need to fight. So flakiness in any sense of the word, you really need to fight this one. You need to consolidate information from multiple places. So why is that? Well, you get from CI, you get unit test result, performance result, log files, whatnot. Okay, all of that comes from Jenkins, from TeamCity, from Bamboo, from whatever you use, Circle CI or others. Fine, but they typically come in different places. So if you have 10 instances of Jenkins, you're going to have to click 10 times to go to the different places. And you also have to click on one side to go to the unit test and the other tab to go to the logs and so on. So as a brain, it's really hard to go everywhere and make sense of all of that. What you need to put is, you need to put all this information together so that you can make sense of them together. So for instance, if you got a performance test that goes slower and your log files is 50% bigger, maybe there's a link between those two. So what we're doing now, actually, we're building a project where, well, whatever CI system we have, and it actually doesn't matter what it is, we take all logs, we take all test results, we take a lot of things, and we push that in a central place so that we can make sense of it. So you really want, basically at the end, to put the right information at the right time to the right person, and you want to avoid spamming all the organization with like hundreds of potential mails or information that people will very quickly make filters for and send all these emails to trash. So you need to give people context. Context as to, okay, I'm running my test in my PR, and I get a red sign. Something is wrong. Something is broken in my test. Does this result, okay, on the top right here, you got a broken test, right? So build goes this way. That's a history of my branch, and the other side is all the tests. So one of them got red. Of course, this one needs to be fixed, right? You understand this one is red. But this one is red as well. Is that the same thing? Of course not, right? You realize that the context in which your test is read is not the same. So if you do get something which is broken in your code, you need the context of that. You need to know what it was before. You need to know if the test was flaky, if it was not flaky, if the reason because it failed is the same one as before or not, if other tests are failing as well or not, if that's the only one, if that's a brand new test that just got created and you need to fix it. But you see what I mean? It doesn't tell you anything to have a snapshot of one build or one state of your code. You have 5% of the information you need in order to fix it. And you want people to look at stuff that matters. We have hundreds or actually thousands or dozens of thousands of tests that are run. The only one you care about are the risky ones, the ones that have problems. The rest you really don't care. So what do? Well, you just order them. So you see like the one on the top are more problematic than the one on the bottom. Right? So why do you need to send all that information to everyone in a random order? Of course not. You need to help your developers focus immediately on the stuff that matters to them, which is the risky part of your code or the risky test. Another thing is like, if I'm a developer and I get a performance regression, for instance, I need to know, what does that tell me to have a performance problem? Well, I need probably to talk to someone, or maybe I just need to fix it myself. But basically, let me give you an example of what you actually need. You need that. You need that, okay, something has been run. Suddenly you got a drop in, say, I don't know, whatever, memory, time to do something, whatever. Something is measured and something changes brutally. And that's usually what happens when you make a performance test. You have got big changes in one go. Well, what you need to know is who did that. I'm talking about test on master here. Who did that? Why? Which ticket was that? what is the context of that run, which machine was that run on, everything. You need to know all of that. And the information typically exists on your CI environment. The problem you have is that it's scattered in so many different places. You need to consolidate all of that and send the information that matters to the person who is interested by that, and do not send them information they don't care about. So a typical case is you can actually collect information about tons of tests, collect, for instance, the time they take to run, collect all of that into a database, and make this analysis automatically. You only send to the people the graph that have a big drop or a change. You don't care about the rest. Basically, once you have this database where you store everything, just let the developers develop by themselves their analysis tools. They are fantastic for that. And basically, they can do a lot of things by themselves. So, as a developer doing something in my code, the only thing I really care about is the impact of my change on everything else. So if I'm typically working on the low-level stuff that typically plays the music in Spotify, then what I really want to know is in which way is that going to impact anyone that I can think of in the organization. And the rest I really don't care about, but I do care about that. And I want the system to not send me any information that is not related to my change, and I want the system to send me all information related to my change on everyone so that I can talk to them if the change I made is actually necessary but breaks their own features. I'm now talking about deltas. Remember what I said about the size of the code? The size of the code is basically one full life to read or to understand. But really, when something worked before, and now it doesn't work anymore, and you did not find it during continuous integration, but you did find it during, say, deployment, because, I don't know, you got millions of people listening to the music at the same time, and then suddenly things start to happen. What you really want is to be able to see the difference there is between the time it worked and the time it doesn't work. The only thing you care about is the difference. Remove everything else. So, for instance, test coverage. The code coverage, I don't care about the percentage of that. What I really care about is the 2 lines that got covered or not covered by your test. What I really care about is the code that has changed. And by the way, the code you just modified from point A to point B, is it test covered? I want to know that thing. The rest of the test coverage for the rest of the organization, I really don't care about. I also want to see which exact performance test has changed. Like value, like statistically speaking, it's actually very different. I really don't care about the other ones. So you can reduce dramatically the amount of information that you send to people by just collecting only what matters. For instance, even logs. Look at all the logs that you have and put some intelligence in that and try to find what has changed. Only what has changed. So basically, you do something like that. You got like a first commit, you got another commit, maybe you got 1,000 commits in between, and the only thing you look at here is the things that have changed in between. That basically reduces a lot the load on the brain of your developers, and that enables them to focus on what matters. So now it's not red anymore, it's blue. It's just a fact of life, that's how we live. But we can build a continuous integration, continuous delivery. We can build that for taking that into account by, again, removing, making shortcuts, and giving people actionable data. But now, some magic. So now you've collected data for, like, say, 2 years. You have a lot of information given which ticket has been implemented, which way, in which part of the code, which test broke, what performance tests got impacted by what change. You got a lot of things into this database that can help you do a few things which really make a very big difference. Test priorities. If you got a big code base, only the time to run those tests is simply impossible for every commit. Like if you make, I don't know, a few thousand commits per day, and you got tests that run for a few hours, just do the math. I mean, we have hundreds of built agents, but it's just not enough. It doesn't scale. But what you can do is you can make correlations between when this team touches this piece of code, most likely they're going to break that code. You can do that, right? Just statistics. Don't try to put any judgment in that. It's just a fact of life. You just like the statistics. And what that means is that you can prioritize the tests you want first, or actually the tests that are most likely going to break. And believe me, you can reduce by a factor of 10 the average time it takes to find a regression, only by doing this. That is kind of useful. So basically what you do is this. You do the exact same architecture that we had, but you prioritize those tests. And you can even go further than that. If you simply don't have time to run those tests, because physics, you don't have enough CPU cycles to do that, what you can do is, whenever there's a change, you collect all the stuff you would like to run as tests if you had time to do that in a same place, and you put all this bucket with all the stuff that would be so nice to be able to run as unit tests, for instance. Then you can prioritize that. And you will prioritize first the latest build. So if you have one build that runs, is green, you don't have time, you don't have time, you don't have time. OK, now you have time to run it. If it turns green, you don't care about the ones in between. You just drop them. But if it's red, then you enter bisect immediately. And then you know exactly which commit it is that broke. And that is a super efficient way. It scales super well. You can also try to influence your developers by that, by saying, I'm going to prioritize the tests that are faster to run. So if you want your tests to be run often, make them fast. Just saying, it may help. And again, you can also prioritize the tests that are most likely going to fail because you know which file has been changed. And when you change that file, it breaks that code, statistically. You can try to make some interesting statistics as Team A works pretty well. They push a lot of code. Statistically speaking, you know that Team B is going to slow down for some reason. I mean, it's not very obvious sometimes why that happens. Sometimes it's plain obvious because you're touching something which is core and the other one gets impacted by the changes. That's sort of easy. But sometimes it's not obvious at all why there is a relation between those teams. But as management, you know that if you put a lot of pressure on one part of the company, maybe you're going to slow down this other part of the company. And that helps you predict when you can release something. Basically, we're talking about big data. We're talking about analytics. We always talk about analytics when it comes to collecting data from your users. Hey, you forgot someone. You forgot yourself. Please treat yourself as a source of big data that will help you basically analyze your own development processes, that will help you prioritize what needs to be run first, that will help you understand which team is struggling and which teams get impacted by everyone else. And then basically you can improve a lot your velocity. I would like to say thank you. Thank you for GitHub for inviting me.